Welcome back, students. So in our last video, we were talking about how do we determine if it's a linear or a nonlinear function given a graph. And in our video here, we're going to determine if it's a linear or nonlinear based off of a table without having to graph the points. And so in our first video, we talked about that a linear function was a function that has a constant rate of change or a constant slope. And so what we're going to do is we're going to find slope for every pair of tables in or points in our table, and from there we'll determine if they're constant, making them linear, or not constant, making it a nonlinear. So we're going to start with doing 8 minus 5, which is 3, and then 2 minus 1, which is 1. And so between these 2 points we have a slope or a rate of change of 3 over 1. And now I'm going to do it for my next two. So 2, 8, and 3, 11. We're going to do 11 minus 8, which is 3, and 3 minus 2, which is 1. And then I'm going to do it for my next. So again, we have a rate of change of 3 over 1. We're going to do it for 14 with 11. So 14 minus 11 is 3, and 4 minus 3 is 1. And you may be saying, well, Mrs. Cartwright, why do I have to do this for every set of points? And the reason is you could have a mean teacher like me sometimes. And I know I did it in my Algebra 2 where I was wanting students to check all of the points, and so at the end of the table is where I put the non-linear points instead of at the beginning of the table. So that's where you want to check all of them to make sure that every point is indeed the same distance from the other. And we have to do both the y and the x because one of them can be constant whereas the other is not. And so that's something we have to keep in mind. All of our y's have a difference of 3 and all of our x's have a difference of 1, which makes our rate of change 3 over 1 because change in y over change in x, or 3. And because it has a rate of change, this is a linear function. All right, moving on to the next table, if I do 5 minus 3, I get 2, and 1 minus 0 is 1. And 6 minus 5 is 1, with 2 minus 1 being 1. And then 5 minus 6 is actually a negative 1, with 3 minus 2 being 1. And then 3 minus 5 is negative 2, and then 4 minus 3 is 1. So notice how our x values have are constantly increasing by 1, but our y values are kind of jumping the board. And so because it's not a constant rate of change, this is a nonlinear function. All right, now we're going to move on to our next set of tables, and we're going to determine whether these tables represent a linear or a nonlinear function. All right, so and I'm sorry if this is repeat, we're going to determine whether or not, there's the table, this table is linear or nonlinear, and then we're going to explain. So we're going to start by doing negative 16 minus a negative 8. So that negative becomes plus a positive. So when I do negative 16 plus 8, I get a negative 8. And then I'm going to do 2 minus 1, which is 1. Then we're going to do negative 24. And if it helps, write it out. Negative 24 minus a negative 16. And we're going to do negatives plus a positive. So negative 24 plus 16 is a negative 8. 3 minus 2 is 1. And then we're going to do negative 32. Negative 32 minus a negative 24. Make this plus a positive. Negative 32 plus 24 is a negative 8. 4 minus 3 is 1. And then finally we're going to do negative 40 minus a negative 32, which makes that plus a positive. And a negative 40 plus 32 is a negative 8. And 5 minus 4 again is 1. So here we have a constant rate of change because on the y's they're all a difference of negative 8 and the x's are all a difference of 1. And so this is a linear function. And that's because our rate of change, so because we have a rate of change. All right, on to the next one. We're going to do 2.5 minus 1.5, which is 1. And 2 minus 1 is 1. And then we're going to do 5.5 minus 2.5, which is 3. And 3 minus 2 is 1. And at that point, right there, I know we don't have a constant rate of change. And so this is going to be a non-linear function. And the reason is no constant rate of change. All right, next one we have from 3 to 1, which is 2, and 2 minus 1, which is 1, and then 6 minus 3 is 3, and 3 minus 2 is 1, and 6 minus 10 is 4, and I don't know why I went ahead and went on, because at that point when we had the 2 and the 3, I should have said to myself, oh, I know that this is not a constant rate of change, and so this is also going to be a non-linear, and it's because there is no constant rate of change. All right, moving on to example 4. All right, so we just finished these tables, and in our next video we're going to do some word problems for both a linear and a nonlinear function. I will see you there.